there was a statement in the materials that you had today that we can use a linear function to approximate any function that changes smoothly over a short enough interval. So if we have, let's say, a depth versus clock time function, and we don't want to bother calculating all the quadratic terms, and we're content with a fairly good approximation, we could approximate the function between clock time t1 and clock time t2. If our function is f of t, then we have coordinates t1 f of t1 and t2 f of t2, and we'll be making a linear approximation between these 2 points. So we want to write down the equation of a straight line between these 2 points. And we can see that if the points are close enough together, this linear approximation is going to be pretty close to the actual value of the function. If the points are further apart, the linear approximation gets further apart. And actually there's somewhat better ways of doing a linear approximation. If we zoom in just a little bit so that we can read what we've written up here, we see that if xy is a point on this linear approximation line, then y minus f of t1 minus t minus t1, which is the slope between the arbitrary point xy and this point, is equal to the slope between the 2 points, f of t2 minus f of t1 over t2 minus t1. Just writing the slope equals slope form of the equation of the line. And then we can easily enough solve for y once we get the numbers in the appropriate places.